Good afternoon everyone. We are going to start off with the second module. Now for the second module, the syllabus is transformation of stress and strain at a point, principal stresses and principal strain, invariants of stress and strain, hydrostatic and deviatic stress, spherical and deviatic strains, maximum shear strain. First I'll complete all the stresses, later on we'll take up the strain part. Okay, so first we are going to deal with stress. So in the last module we had discussed about boundary conditions. There we had written Lx, Ly, Lz, so that is nothing but the direction cosine. First let us see what is this direction cosine. Okay, so we have module 2. We'll start with the direction cosines. Alright, so what is this? First let us consider a three-dimensional object. For boundary conditions I had just drawn a two-dimensional plane and then we had just written an outward normal over there. Now I am going to write a three-dimensional object here. Alright, I've considered plane object like this. Yes, let this point be C, B and A. Let us consider this as origin and let me draw an outward normal N. This is our outward normal, that is N. Let's just consider a point P somewhere over here, say. Okay, I've considered a point P. So we have considered a general A, B, C plane with its outward normal N. Okay, the direction of this normal is going to be defined by using the direction cosines. First let us mark the angle of inclination of the normal N with respect to X, Y and Z axis. Yes, and then the point P will be having the coordinates X, Y, Z. It's a 3D plane, hence X, Y, Z. And the distance of the point P from the origin is going to be small r. Alright, so first let me just draw the angles. Say the angle is going to be alpha. Let us consider alpha with respect to x axis, and then I'll consider angle beta with respect to y-axis and angle gamma with respect to z-axis. So we have alpha with respect to x-axis, beta with respect to y-axis and gamma with respect to z-axis. So if I just want to draw, say, something like this, this is how the point is going to drop. Onto every respective plane. Alright, so the next is point P. I'll just write the coordinates of point P, that is x comma y comma z. Alright, so we had written L of x is, or Lx or L of x is equal to cos alpha, Ly is equal to cos beta. Therefore we have the third component, Lz is equal to cos gamma. Okay, and we have written that r is the distance from O to P. So I can write this as the coordinate z can be written as r cos gamma or rl3, and then I can also write y is cos r cos beta or rl2, x as r cos alpha or rl1. So what do we understand by this is L3 is cos gamma, L2 is cos beta, L1 is cos alpha. Yes, so we have L1, L2, L3, which are the direction cosines of the line OP, and R I can consider it as a polar coordinate of point P. Therefore I can write x square plus y square plus z square is equal to r square. If I divide the entire equation by r square, I'll have x square by r square plus y square by r square plus z square by r square equal to 1. Or I can write L1 square plus L2 square plus L3 square is equal to 1. I've just used this. I've just taken this as x by r is cos alpha, or I can just write it as L1. X square by r square is nothing but L1 square. I've arrived this from this. Okay, so this is direction cosines. The next topic is the transformation of this axis. I'll continue with this because we are going to consider the same diagram or the figure that is drawn. So you have O, A, B. I'm going to consider the plane in XY. I can write area of O, A, B by area of entire plane ABC is equal to cos alpha or L3. Okay, similarly I can write area of OAC divided by area of ABC as cos beta or L2, and then I can write area of OBC divided by area of entire plane ABC as cos alpha L1. So this is not confusing. I'll give you a small hint how to remember this. ABC is the total area, so that is going to be in your denominator. We have used gamma. Gamma is the angle that is going to be inclined with respect to the z-axis and the outward normal. So z-axis. So this OAB lies in XY plane. Okay, beta is angle inclined by y-axis and outward normal. Y-axis and then outward normal. So other two planes are A and Z. So it is OAC. OAC. The last one, alpha, is angle inclined by x-axis and outward normal. So it is YZ plane. YZ plane. That is nothing but OCB or OBC. Alright. Then let us consider XYZ plane, X, Y and then Z plane. So we have talked about transformation of these axes. Let us say that the axis gets rotated by some angle. So the latest coordinate axis becomes x dash, y dash and z dash like this. Okay, so we are going to arrive at the direction cosines of the latest axis or the transformed axis. So from this I can write like this: area of plane ABC is, say, delta A. Okay, I just cross multiply and write it. Area of OAB is delta A times L3. Area of OAC is delta A times L2. Area of OBC is delta A times L1. Okay, so we are going to consider this and then we are going to write. So we have initially three axes x, y, z. Then we have considered three more axes that has oriented differently to x, y, z. Therefore, the new axis is going to be x dash, y dash, z dash. Alright. So, the stress that is going to be developed in x, y, z will be transformed to x dash, y dash, z dash. I'll just write it. Stresses developed in x, y, z system can be transformed to x dash y dash z dash system. How? By using direction cosines. So you need to understand this concept because you will be having problems related to this. They are going to give you that the stresses that are generated in xy plane, there will be some equations like sigma x is equal to some equation, sigma y is equal to some equation, sigma z, similarly your shear stresses, everything. They are going to ask you to find out the stresses that are going to be generated in the new coordinate axis if one of the axis, say z axis, is transformed through 45 degrees. So in order to find out the latest stresses, you need to make use of the direction cosines. I can write a table like this to show the transformation and then the corresponding values of direction cosines. This is x, y, z. This is x dash, y dash, z dash. The values are L1, L2, L3, M1, M2, M3, N1, N2, N3. So if you're dealing with x axis, direction cosines are L1, M1, N1. If you are dealing with x dash axis, then the direction cosines are L1, L2, L3. Okay. So similarly, it is going to vary. Whichever axis that you're trying to deal with, correspondingly, it is going to vary. Alright. I can also write this as L1 square plus L2 square plus L3 square is equal to 1. How do we know this? It is because we have solved it over here. Okay, the direction cosines. Similarly, I can write m1 square plus m2 square plus m3 square is equal to 1. And then n1 square plus n2 square plus n3 square is equal to 1. Alright. Now, let us say we are going to consider two lines such as OX dash and OY dash which have different direction cosines L1, L2, L3, M1, M2, M3. I am talking about X dash, Y dash. Okay, it is drawn something like this. This is X dash and then this is Y dash. We know that the angle between them is going to be 90 degree. So direction cosine of x dash is what? L1, L2, L3. L1, L2, L3. Direction cosine of y dash. Direction cosine is usually written as DC. Okay. Direction cosine of y dash is M1, M2, M3. M1, M2, M3. Now, say if I can represent the angle between x dash and y dash as something like psi. Okay, I can write the value of cos psi as L1 M1 plus L2 M2 plus L3 M3. Okay, I've just cross multiplied them with respect to each other, but we know that psi is 90 degrees or cos 90 is nothing but 0. So L1 M1 plus L2 M2 plus L3 M3 equals 0. Similarly, the other two combinations we have L, M, N. In a cyclic order, it is going to vary. Okay, I can write M1 N1 plus M2 N2 plus M3 N3 equals 0. The third one, N1 L1 plus N2 L2 plus N3 L3 equals 0. Alright, so this I can call this as equation 1 entirely, and this I can call this as equation 2 entirely. So equation 1 and 2, these are used to obtain the 9 direction cosines between two sets of axes. Okay, this is how we are going to find out the direction cosine between two sets of axes.